Hi, I'm Tom. I'm Granulate's VP Product, and I'm gonna do a quick live demo today to show you how Granulate work. Um, Basically, what we see here in the Grafana is a live demo of a microservices-based request response architecture, and it's actually a representation of a workload of one of our customers. That's a tech workload written in Python, and we have here five front-end servers. Each of them generate requests simultaneously to 10 backend servers. And if we look on the five front-end servers, we can see that all of them operate in very similar performance metrics or performance rates. So in terms of throughput, they all operate at around 120 requests per second. In terms of latency or response time, you can see here there's a median latency is around 32 milliseconds. The P90 latency, which means that 90% of the requests are faster than 44 milliseconds, and they all are very similar in terms of the metrics. And the CPU utilization is around 61, 62%. So all in all, it looks like a well-optimized service or workload. And what I'm going to do is I'm going to activate Granulate on one of those machines, and you'll be able to see the performance difference. So I've logged in to a specific machine that ends with 69. That's the last machine here, the red line. So we can see that it's very similar to the other line, actually equal to the other lines in terms of performance. And I can activate Granulate. I'll show you how the activation looks like. So the activation is basically loading a kernel module into the kernel. The kernel module dynamically loads the runtime module into the runtime manager, and it loads it with the initial configuration that has already been learned. Here we have the configuration, and we are optimizing for latency. That is the utility function. And once I activate it, within seconds, the kernel module is dynamically loaded, so there's no need for any restart of the process or server. And within seconds, it starts making decisions regarding resource management within the kernel, applying different prioritization and scheduling logic. And if we check the metrics that is being monitored on the servers, we see that the servers that we activated on suddenly start acting or start performing much better and much faster. So the first thing that we see is the latency dropping. So it has dropped from around 33 milliseconds to 22 milliseconds. So that's 11 millisecond decrease, a 33% decrease in the response time. Also, the tail latency, the IO ranges latency have dropped as well from around 43 to 44 to 35. It's also around 20% decrease. And the response time, the throughput has been increased. So we're looking at 143 requests per second compared to the other passive ones that are operating at 114 requests per second. So another almost 30% increase in response time. So each machine is dealing with each request much faster. It also handles more requests. And what's very interesting to see is that the CPU utilization remains the same as the other machines. That is because Granulate allows to take more effective usage of the resources and specifically the CPU itself. Now, if I want to deactivate Granulate, it looks pretty much the same. You just remove the kernel module, and it also removes the runtime module dynamically without affecting the application or the server. And once I deactivate it, because what Granulate does is basically algorithmic changes of prioritization and logic inside the kernel without replacing any code. After it has been removed, the machine goes back to the resource management within the kernel that it did as before, and it gets back to the same performance as before. In this specific case, a worse performance or a less good performance in compared to when Granulate agent was activated. So it's very frictionless, very seamless, autonomous optimization that drive significant benefit to the top line metrics that businesses are already monitoring today.